Okay, we're back. We're going to do Chapter 4, Section 3. Polynomial division. The remainder theorem. And the factor theorem. So let's first look at what it breaks down into. A polynomial can break down into different parts. All right. So for example, if our polynomial was x squared plus 5x plus 6, we learned earlier that we could factor it out to x plus 3, x plus 2. So this part here, the question part, is called the dividend. This little d is called the divisor. This is what you divide by. This is called the quotient. And this is called the remainder. And this part here is going to be very important to us when we start looking for it, because we'll find out that if there's no remainder, that means these are the actual factors. And then we can figure out what the zeros are. -3, -2. Those are the actual solutions to the equation. There is no other one. Let's look at an example. We're going to do long division here. Now, in this section, we're going to do two things. We're going to do long division and something called synthetic division. This will help us figure out if a number or an equation is part of a polynomial. Long division, we're used to doing this. If we had to say a divided by b, we can rewrite that as b goes into a. Now, the difference between long division and synthetic division is that notation. And in synthetic division, we don't use letters, only numbers. In long division, we use everything. So let's look at example 1. Divide to determine whether x plus 1 and x plus 3 are factors of this. Now, what we're looking for here is this. If the remainder is 0, then it is a factor of the polynomial. If the remainder is 0, then it is a factor. If not, then no. So let's look at this. Let's do the first one. X plus 1 goes into x cubed plus 2x squared minus 5x minus 6. This is long division. To do long division, we always look at the leading term of where we are. What times x gives me x to the third power? Remember, there's 1 already here. I need 2 more. So it's x squared. Now, take this number and multiply both of those. X squared times x is x cubed. Positive times positive is positive. X squared times 1 is x squared. Change their signs and add. This first term should always cancel. If it doesn't, then you did something wrong. So 2x squared minus 1x squared is x squared, and bring everything else down. Repeat the process. What times x gives me x squared? A positive x. X times x is x squared. X, or positive times positive is positive. X times x, or x times 1 is x. Change the signs, what we just put down, and add. Those cancel. Negative 5x minus 1x is negative 6x minus 6. And look at the first terms. What times x gives me negative 6x? Negative 6. Negative 6 times x is negative 6x. Negative times positive is negative. 6 times 1 is 6. Change the signs and add. Since the remainder is 0, x plus 1 is a factor. Now, if this remainder is 0, we know that's a factor. We know x plus 1 is a factor of it. All we have to do now is take this answer here and factor that one out for the last 2. Because we're supposed to have 3. There's one of them. We need 2 more. So that's what we're going to do. Now, let's try the other one. X minus 3. X cubed plus 2x squared minus 5x minus 6. Look at the leading terms. What times x gives me x cubed? X squared. So x squared times x gives me x cubed. Positive times negative is a negative. X squared times 3 is 3x squared. Change their signs and add. 2 plus 3 is 5x squared. Bring down the rest. Repeat the process. What times x gives me 5x squared? A positive 5x. Positive times positive is positive. 5x times x is 5x squared. Positive times negative is negative. 5 times 3 is 15x. Change the signs and add. 15 minus 5 is 10x minus 6. What times x gives me 10x? A positive 10. 10 times x is 10x. Positive times negative is negative. 10 times 3 is 30. Change the sign. 30 minus 6 is 24. So x minus 3 is not a factor. X plus 1 is a factor because the remainder is 0. Now, I'm also going to show you a little later how we get these. Instead of doing this whole thing, there are two faster methods we can do. So there we have the remainder theorem. What I just said there is, here's our polynomial divided by that. What times x gives me 4x cubed? 4x squared. Multiply that and that. And don't worry about this. We'll do that in a second. The remainder theorem pretty much says that is if your remainder is 0, then that is a factor. Now, let's look at synthetic division. It only works if you divide by a linear equation in the form x plus or minus some number. If x is by itself, no coefficient, no exponent, and you have a number, then you can use synthetic division. The way you do synthetic division set the denominator equal to 0 and solve for x. So first thing we have to do here is take our denominator, x plus 3. So x is equal to negative 3. So that goes outside the dividing. Remember, synthetic division looks like that. That value goes outside the under upside down thing. Inside that upside down thing, place the coefficients of the numerator, or the top number. So. Notice there's three. It's all, I always start here, the degrees here. We have 3, 2, 1, 0. So which one has an x with a 3? The 2. Which one has an x with a 2 on it? The positive 7. Is there an x with a 1? No. So we put a 0 there. And the last one is a negative 5 because it doesn't have any x's. You have to allocate each x has to be in there. Bring down the first term. I'll bring down this first term, 2. Multiply negative 3 by 2. So negative 3 times 2, multiply that, place the answer there. Then add straight down. 7 minus 6 is 1. Repeat the process. Negative 3 times 1 is negative 3. Add straight down. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. 9 minus 5 is 4. This is your remainder. Since it's not 0, x plus 3 is not a factor of 2x cubed plus 7x squared minus 5. Remember, you have to tell me what the answer is. And see, the beautiful thing about the synthetic division, look how small, it doesn't take much room at all. Let's go back to the original 2 that we did. Let's do synthetic. Since the x plus or minus a number, we can do synthetic. So with this one, we get x equals negative 1. And this one, x equals 3. So we have negative 1. And then we have 3. So we have the coefficients 1, 2, negative 5, negative 6. 1, 2, negative 5, negative 6. Bring down the first term. Now it's a process of multiplication addition. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Negative 5 plus minus 1 is negative 6. Negative 1 times negative 6 is 6. Add those, we get 0. We got the same thing. It's a lot faster doing it that way. Three times 1 is 3. Add straight down. 2 plus 3 is 5. 3 times 5 is 15. 15 minus 5 is 10. 3 times 10 is 30. 30 minus 6 is 24. Yeah, synthetic division is much easier. Okay, there's a third way we could do it. When we took the equation, set it equal to 0 and solve for it. If we took this value here, and if we plugged it inside there, -1 cubed plus 2 times -1 squared. I just put inside the function. -1 cubed is -1. -1 squared is 1. Negative is a positive 5. We have -1 plus 2 plus 5 minus 6. -1, -6 is -7. 2 plus 5 is 7. 0. There we have it. Do the same thing. If we plugged in 3 in this equation, the answer would be 24. So there's 3 ways you can do it. Let's look at example 3. What this one says is plug 10 inside anywhere you see an X, plug a 10. That's a 5. 10 to the 4th, 10 cubed. Ten to the 5th is 1 with 5 zeros. Ten to the 4th is 1 with 4 zeros. 10 to the 3rd is 1 with 3 zeros. 10 squared is that. We have 2 with 5 zeros. 3 with 4 zeros. Minus, plus, minus, plus, minus. That's what it's asking us to do. So 10 minus 8 is 2. So we have 200 plus 2 is 202. So that equals 202. So we have 1000 minus 202. You have to borrow 1 because 10 minus 2 is 8. 9 minus 0 is 9. 9 minus 2 is 7. So now since it's a positive, we take -3 Ooh, hold it. No, this. Oops. That's a positive 2. This would be a negative 198. I bet. So that's a positive 2. So it's negative 200 plus 2 is a negative 198. Take a positive 1000 minus 198. 208. It's positive. Then we take a negative 30,000 and add 802. Again, the answers will be negative, so we subtract them. Eight, 9,192. And then we have the 200,000 minus the 29,198. So it's 20807. There's the answer. So it's not 0. So it's f of 10 will be 170802. Yeah, it's the same as we did last time. Is what this one says here is f of negative 3. That's what we had here. So that's division. So if we put negative 3 inside this function, we should get 4 as an answer. Negative 3 cubed, negative 3 squared, negative, so it'd be negative 3 times 3 times 3 is 27. Positive times negative is negative. No, it's positive times positive is positive. 9, 7 times 9. Negative 54 plus 63 minus 5. These two together make it negative 59 plus 63. Answer is going to be positive. 63 minus 59 is 4. Again, you could, that's why you could do it to check to see if it's a 0 or check your answer. Example 4. Determine whether 5 is a 0. Well, just if 5 is a 0, let's check it out. If we plug it in there, what we're saying here is if this is our 0, then x equals 5. Since x equals 5, I put it in there. 5 to the 4th, 5 squared, 25. 5 to the 4th is 5 times 5 times 5 times 5. So it's 25 times 25. And 625. 26 times 25. So 26 times 25. 6 times 5 is 30. 10 plus 3 is 13. 2 times 6 is 12. 0, 5, 6. 625 minus 650. 625, 25 is 650 minus 650 equals 0. Yes, 5 is a 0. So with the same equation, since another way we could have done it, since we said x equals 5 is a 0, if we make this equal to 0, we got x minus 5 equals 0. So we can see that if that's a factor. If that's a factor, then we can do long division. X to the 4th plus 0x to the 3rd, 26x squared plus 0x plus 25. Look at the first term. So it's x cubed. X cubed times x is x to the 4th. Positive and negative. 5 times x cubed is 5x cubed. Change signs and add. So we have 5x cubed minus 26x squared, bring that everything else, plus 0x plus 25. What times x is 5x cubed? It's a positive 5x squared. This is going to be one less than that one. Positive, positive is positive. 5 times 1 is 5. X squared times x is x cubed. Positive times negative is negative. 5 times 5 is 25. X squared. Change signs. Negative 26 plus 25 is negative 1x squared. What times x gives me negative 1x squared? It's negative 1x. So it's negative 1x. Negative 1 times 1 is negative 1. X times x is x squared. Negative times negative is a positive. 1 times 5 is 5. X. Change the signs. So it's negative 5x plus 25. What times x gives you negative 5x? It's negative 5. Negative times negative is a positive. 5 times 5 is 25. Change the signs and add. Yep, so same thing. Or since he gave us the phi 0, we could have done synthetic division. Because since it gave us a 0, we could put it in that term so it satisfies the condition. So we put a 5 here. So this is x to the 4, 3, 2, 1, 0. So the coefficients. Yeah, there's 1 x to the 4th. There's no x cubes. Negative 26 x squares. No x. That's what that says. Bring down the first term. 5 times 1 is 5. Add straight down. 5 times 5 is 25. add straight down. So negative 26 plus 25, -1. 5 times -1 is -5 equals -5. Add straight down. 5 times -5 is -25 and 0. All of those things work. Determine whether I is a 0. Ooh. So we have this x cubed squared 1, 0. So it's -3, 1, -3. Bring down the first term. I times 1 is I. Add those, so it's -3 plus I. I times that makes it -3 plus I, -3I plus I squared. That becomes -3I minus 1. Add those together, the ones cancel, so we have -3I. I times -3I is -3I squared. This becomes a negative, it changes that sign, so it's 3. -3 plus 3 is 0. Yes, I is a 0 because of the remainder is 0. The factor theorem. This is the last one we're going to talk about. For the polynomial f of x, if f of c equals 0, then x minus c, that's what we just said, is like we had f of 10. If that equals 0, that's our x value, x equals 10. Subtract it, we get x minus 10 equals 0. If we solve for x, if we set it equals 0. So if this is true, that means that's a 0. That means this is a factor of f of x. Before we do that one, let's look at an example. So my function is x squared plus 5x plus 6. Let's try -2. -2 squared plus 5 times -2 plus 6. -2 squared is 4. Positive negative is 10. 6 plus 4 is 10. So since it equals 0, we know that x equals -2 is a 0. Set that equals 0. We have x plus 2 equals 0. So this is a factor. Since that is that's a factor, we can either do long division or we can use synthetic division to find the other part of the factor. So it's 1, 5, 6. -2 times 1 is -2. -2 times 3 is -6. This is our remaining factor. This is a constant. This is x, the next one would be x squared and so on and so forth. So x plus 3 is another factor. So what we know is f of x equals x squared plus 5x plus 6. That the two factors are x plus 2 and x plus 3. We just figure that out. Once you find 1, 0, you don't have to go to the entire thing. Just see what you have left over. Since that's a 0, these are your constants. These are your x values. The next one's the y, x squared, and so on and so forth. So let's look at this. Let this be our polynomial vector and solve the equation for that. So what this is asking for is find all the x-intercepts. So what we're going to do here, we first start off with x equals positive 1. We could use synthetic division. So we know this is a solution. Since x equals 1 is a solution, that means x minus 1 equals 0. That's a factor. This is a solution. This is a factor. We're supposed to have 3 of them. Well, we don't have to go here anymore. We can just go straight down to here. That's our constant. This is our x term. This is our x squared. We don't have to do any more. Since this is quadratic, we can try to factor it, see if it works. So x times x. It's a negative sign, so one's positive, one's negative. The bigger number is going to have a negative. So what times what equals 8? When we subtract them, we get 2. Four times 2. So that's a 4, and that's a 2. Since these are the factors, then we know that f of x we know the factors of it, all 3 of them, is x minus 1, x plus 2, and x minus 4. Those are the factors. Now, since it wanted f of x equals 0, we know the zeros are at 1, negative 2, 1, negative 2, and 4. Those are my x-intercepts. Now, if 1 didn't work, I would try negative 1. If those didn't work, I'd go to 2, negative 2, 3, negative 3, 4, negative 4, and just keep going down till you find as many, till you find enough so you go down to quadratic equations. Okay, I hope I didn't confuse everybody too much, but that's the first 3 sections. I want to make sure you understand these before we go on any further, because the next 2 sections are going to be the most complex ones. We deal with a lot of theorems here. But I want to make sure you understand how to find the factors and the zeros and what they all mean. So that's